In this video, we are going to see how to solve this map. Okay, here the scale is given. .5 centimeter equal to 500 meter. That means 0.5 centimeter equal to 100 meter. So we have to draw a cross section along XY and we have to calculate the dip and we have to find out which fault is younger and which is older. Now when you see this map, we can see different type of layers A, B, C, D, G and H. So from west to east we have different formation. We have a fault F1 and the F2, F2. And when you see that here the fault is hidden, a formation is over it. That means this fault is older than this one. So this is a younger fault. This is an unconformity. So here also we have the unconformity. The layer G is here. So G, this one. So the fault occurs after the unconformity. So first you will do the unconformity. Then we will draw the fault and then the different layers. So first I am going to highlight the unconformity using highlighter. So this is our unconformity. And the same unconformity is here. The H layer boundary is here. So this is an unconformity. Now we will start working with this map. Now draw a line. So along this line we are going to make a cross section. Take a fresh sheet of paper. Place it over it. Mark the point as usual. X and this one is Y. Now mark down the contours. $600, $700, $800, $900, $900, $800. So note on all the contour values. Now draw the baseline and transfer this value and draw the topography on a separate sheet. Draw a baseline. Transfer the XY value and draw the vertical lines with the scale. So the horizontal and the vertical lines are drawn and the values are marked as per the scale. So 0.5 centimeter equal to 100 meter scale I am taking. So now transfer the contour values here. All the points are marked. So now the topography is drawn. Next, so we have to draw the structural contour for this unconformity. You see here the inner layer, that is the boundary between D and G, DG. So which is meeting somewhere here and here. So you can join these two, which will meet here also. So I'll use a different color pen so that it will be easy to identify the structural contour. We are getting two or three structural different type of structural contours. I am using some other color pen. And if you look at again the same, so this is a 700 contour, 700 contour. So the same bed is intercepting at here 800 contour, and this one at 900 contour. So you can draw the parallel line to this. The structural contour for the unconformity is drawn. Okay, we have three structural contours. Now you write down the values for this unconformity. So I am using unconformity UC. So this is 900. So this is UC 800 and UC 700. So this is decreasing towards east, and you can see that the same unconformity is cutting somewhere here at 800. So I am writing another value 800. So this is east and this is west. That is, after the fault there is a rise of 100 meter. Got it? So after the fault the value is increasing. Okay, so western side, the fault, western side of the fault it is 700 and eastern side of the fault it is 800. So now we have written the value. Take the same strip of paper and now note on the unconformity structural contours. So make it up 900. So this is 800. So this is UC and 700 west and 800 east. Now plot it here. So this is the unconformity which is present here. Okay. Now this side we have a fault also. Fault. For that we have to draw the fault. Now let's see how to draw the fault. Let's start the fault F2. So you can see the intersection of contours with the fault. If you try to connect all this fault, it's in a straight line. So you can see 700, 700, so 800, 800, so 700, 700, 800, 900. So it's a straight line, it is connecting. So it is a vertical fault. So this is a fault. So plot it here. So this is a fault F2. Okay. So the fault F2 is marked here. Now we try to draw the unconformity on both sides of the fault. So first the eastern side you take it. So we have 900, 800 and 700. Now try to draw in the eastern side. So here it is 800. That means this one become 900. So 2 points is sufficient. Draw a line. So the boundary between G and D was drawn. G and D. So we have another boundary G and H. So that you have to mark. So the western side of the fault, if you see that, this value become 800. So the boundary between DG equal to 800. So if you come to the other side, obviously it is 100 meter up, so that is 900. So now here this is increasing, so you have 900 for DG, this is 1000. Okay. So here you can write, so this one become west, so DG, so boundary between D and G, here it is 800, so that means east it will become 900. So here it is 900 and here it is 1000. Now plot it in the cross section. First you will mark the western side. So 800, and this is 900. So this is H. And in the eastern side of the fault, we have this is 900. So that this has become 1000. Now connect these two. So this is H. Now the unconformity is marked. So we can give a zigzag line here to distinguish between the unconformity. So now it is plotted. Now you try to plot the fault F1. So this is also the vertical fault. So you can see that all the contours are striking in the same line. So it is a vertical fault. So this is F1. So this one is F2. Try side straight line. So this is fault 1. So you can see that the fault 1 is below this unconformity. Now you can see different type of beds are there. Now try to draw the structural contour for all these beds. So let's start with this bed, the boundary between B and C. I'm taking this one, or you can take this also, boundary between A and B. So the 400 is meeting here. So now you see that this unconformity is striking in this direction, whereas this one is like this. The strike direction of the structural contours is like that. The strike direction of the unconformity and the beds are different. Okay, so the strike direction of bed is this direction, whereas the unconformity is in this nearly the north south direction. Okay, now try to identify other part also, and you try to complete the map. I have used different color pen for indicating the structural contour lines of the formation. Okay, so now I am using a separate paper to mark the values of all these structural contours, because it is very difficult to mark here. So I am using a separate paper so that it is easy to understand and draw. So I have written like this. So in this map, when you are drawing, you have to be very careful. So draw step by step. Okay, start from here. So first between these two, so first fault and this side. Okay, try to plot it. Then in between this, you got to draw. Then only you will get the correct diagram. Otherwise, it will make lot of confusion. So we'll start with here, right? So the boundary between A and B, so 500, 400, so 500, 400, 300. So this is A and this is a B. Okay, the boundary between A and B is drawn. Next, B and C. This is 700. 600. This is 500. So this is B and this will be C. And now you draw boundary between C and D. So see 800, so this will become 900. So this is 1000. So you can keep it here 1000. $900, 800. So you can join these 3 points. So this is D. So now the bed between fault and the west direction is plotted. Now we will draw the east of this fault F1. So the values are plotted here. So the AB boundary, it is 600. You can see the bed is dipping here 600. So downward it is decreasing, so 500 and 400. Next is BC boundary. So BC boundary, so this one. So here you can see the BC boundary. So this is 800. So this is here 800. Next one is 700 and 600. Then CD boundary, of course it is not there, so we can see here somewhere here it is meeting. So the D boundary is actually it's not cutting here, somewhere here it is there, so it is only C, so we can draw directly. Now start plotting these values. Six hundred, 500, 400. A. Next one is B. So plot B. $800. Join this. So this is B and this will be C. When you see here, after this fault we have only one strike line or the structural control line, so it is very difficult to complete it. So you try to draw the other strike line also. So here I have missed one, and in between that measure this interval, strike interval, and draw the structural contours. Likewise you complete all the structural contours, so that it can be easy to complete this portion. Otherwise only one strike line which is not enough to complete the structure. So now, so we have the 700, this portion, this line is 700, so this is 800 and this 600. So the difference between B and the C contour is nearly 300, so you can see here 300. So this is become 500, so this is 400 and this is 300. So subsequently if you reduce it, so the difference is 200, so 200, so here it is 100, 200 and 300. Like you have to so 600, 600, 700, we have 800. This is D. And next is 300. $400, $500. C. So this is 100, 100, 200, so you can join it. So this is A, B, C, D. Now all the bits are drawn. You can color it. So in this portion we have A, B, C, D. It's unconformity G and H. Here A, B, C, D bit is not coming, and we have unconformity. And here A, B, C, D and unconformity. This is F1 and F2 fault. So complete it, color it. Your cross section is ready. This is a cross section output, so you can see the different layers. Now you have to write the geological section or geological history here. So youngest and oldest. Fault 2, that is the youngest one. Next is unconformity. Next, fault 1. Okay. Then we have tilting of bed. Then we have formation of beds. So A to D. Okay, so this is a so from old. So first the formation of beds, then the beds are tilted, then the fault 1 occurred, then unconformity, and finally we have fault 2. So this is a geological history of the